students, this is Sivakumar, 11th standard mathematics, chapter number 1, continuation of exercise 1.2. Now, problem number 9. In the set Z of integers, define m is related to n if m minus n is divisible by 7. Prove that or is an equivalence relation. What's the statement? M minus n is divisible by 7. Here, Z equals set of all integers. Right, now I start with reflexive. For reflexive, you have to consider only one element. The statement is m minus n is divisible by 7. Statement followed by the relation. Statement and relation. M minus, instead of n you have to consider m only, because you have to consider only one element here. M minus m is divisible by 7. Yes, since m minus m that is equal to 0, m minus m that is equal to 0 is divisible by 7 only, because 0 is divisible by any number. Here 0 is divisible by 7. It is absolutely true, which implies m is related to m. Therefore, or is reflexive. Okay. Now we can go for symmetric. For symmetric, first you write the relation, statement, again statement, finally the relation. For symmetric, I consider m is related to n. That means m minus n is divisible by 7. Since m minus n is divisible by 7, obviously n minus m in reverse, n minus m is also divisible by 7. I can give an example. Since n minus m is divisible by 7, we can write n is related to m. Example, let m that is equal to 15 and n that is equal to 1 I consider. Now m minus n that is equal to 15 minus 1 that is equal to 14, that is divisible by 7. 14 is divisible by 7. Correct? 14 if you divide by 7 you will be getting the quotient to 2, remainder is 0. That is called divisible. Now the reverse, and now I take n minus m. What is n minus m? N that is equal to 1, m that is equal to 15, that is equal to minus 14. Minus 14 also divisible by 7. It changes only sign here. Plus 14, here minus 14. 14 is divisible by 7. Minus 14 also divisible by 7. Therefore, if m minus n is divisible by 7 means n minus m also divisible by 7. Here m is related with n. Here n is related with m. Therefore, or is symmetric. Or is symmetric. Finally, we can go for transitive. For transitive, first write the relation. relation m is related to n and n is related to p. We have to consider p here. We have to take two pairs. One should be common. Which one is common? N common. We have to prove m is related to p or not. Okay. Now the next one, statement. The statement is m minus n is divisible by 7. M minus n is divisible by 7 and n minus p is divisible by 7. N minus p is divisible by 7. Which implies I consider m minus n is divisible by 7 means m minus n should be the multiple of 7. That means k1 times 7. And n minus p is divisible by 7 means n minus p, that is equal to some constant k2 times 7. I give an example. I take m that is equal to 25, n that is equal to 4, p that is equal to 11. Okay. Now m minus n I consider m minus n, that is equal to k1 times 7. So 25 and 4. 25 minus 4, that is equal to 21. 21 you can write 3 times of 7. Here 3 refers k1. Okay. So it is 21, that is divisible by 7. How many times? 3 times of 7. Now I take n and p. N that is equal to 4 minus p that is equal to 11, that is equal to minus 7. That is equal to minus 1 time of 7. So this is k2. So minus 1 into 7. So that is minus 7. Minus 7 also divisible by 7. Now I am going to add these two. Therefore m minus n plus n minus p, add these two. If we add here k1 into 7 plus k2 into 7, you have to add the right hand side also. If we add, no, minus n plus n get cancelled, be getting m minus p. M minus p that is equal to here, that is equal to, look at that, here k1 into 7 plus k2 into 7, you can take 7 as common. If you take 7 as common, k1 plus k2 will be there. So you can write k1 plus k2 into 7. That means m minus p, that is equal to some constant times 7. That means that is also divisible by, which implies m minus p is divisible by 7. Now we can write that this is a statement. Now we can write the relation. What is the relation? M minus p is divisible by 7 means m is related to p. Here what I proved finally, m minus p, that is equal to k1 plus k2 times 7. I proved that also, which implies what is m? 25. What is p? 11. 25 minus 11, that is equal to 14. 14 also divisible by 7, because how many times? This is 2 times of 7. Okay, that is divisible by 7. Finally we proved m is related to p. So here which one is common? N is common. Here starts with M and ends with P. We have proved M is related to P. So what it means? M minus P is divisible by 7. Therefore, OR is transitive. We have proved OR is reflexive. We have proved OR is symmetric. And we have proved even OR is transitive. Therefore, finally write the result. Since OR is reflexive, symmetric, and transitive, OR is an equivalence relation. So problem number 9 is completed. So the exercise 1.2 is over. Thank you, children.